All right, we're back with day 14 on Advent of Code, the Regolith Reservoir. The gist of this problem is that we get an input that's these numbers and arrows. These describe lines of rocks in a grid. We're stuck in a cave with falling sand. The sand is falling from this point here down, and they give us an algorithm on how that sand kind of pools up and gets stopped on these rocks. So here's the example. You see this is the first unit of sand that drops. Second one drops to the left, next one to the right, and so on until the rocks get overloaded and it starts overflowing. Now, part one, it says using your scan, simulate the falling sand. How many units of sand come to rest before the sand starts flowing into the abyss below? I thought this problem was a lot of fun. I did some cool kind of visualizations as well. So let's get into it. Here's my input. You can see the inputs are, there's going to be a lot of rocks. So let's go ahead and jump into it. First thing I want to do is define some variables. We have our minimum x, and max y. Looking at the input here, we can see that like x is anywhere from 500 to, to minimum. So we're not starting at 0 is what I'm trying to say. So since we want to build our board from the min x and the max x and the max y, that's why we'll look at those. I'm going to define a type called chord, which is just an x and a y value. I'm actually going to switch to row and column notation later, but for the first part of the problem, we're working in x and y. So I want to define a function to parse the input. We're going to separate these coordinates that we have here. These are all strings, of course, into the type of chord that we defined, so the x and y value. So process input, this takes in an array of strings, which is called lines that we got up here using the read file sync function from the file system library. And we're going to initialize an empty array called all lines as chords. And now we're going to do some processing so that we can push them into this array here. So we'll define another variable called arrows removed, and that's going to be the result of lines.map that returns lines.split on the arrow character with spaces around it. So it'll give us both the left side of this and the right side of this as two elements in an array that will store in arrows removed. And then for each of those, we're going to define a variable called line chords. So we're basically going to turn these things into the chords that we want. We'll split on the comma. We'll get the x, we'll get the y. We'll turn that into a number using the parse int function. And we'll just grab the first element and the second element, which represent x and y. Now we want to make sure we update these variables as we're looping through every element in here. And so we'll take the min of x and min x, we'll take the max of x and max x, and we'll take the max of y and the max y. And now to line chords, we're going to push a JavaScript object of x and y. And all lines we're going to push that to all lines as chords. And then I'll return that at the end. And we're going to call that function, process input, on the lines variable from up here, which we split on the new line character. And I'll console log the min x, and max y. Let me pull up a quick terminal so you can see what those are. Oh, I didn't save. Save. So you can see min x set 479, max x 533, and max y 167. The sand starts falling from an x position of 500 and the maximum y. Let me clear that to clean things up and drop it down. And let's keep moving. Next thing we want to do is create a 2D array of air characters and the plus character at the start. So we want to take in the min x, the max x, and the max y, and we want to return a grid, which is just a grid of strings, so 2 by 2 array. So let's define an empty array called board. We will let num rows equal max y plus 1. We will let num calls equal max x minus min x plus 1. So that's getting essentially the width of our board and then adding 1 for the 0 index offset. And let start call equals 500 minus min x. This is taking min x as an offset because we know 500 is the starting point. So this is just 0 indexing everything to a grid that starts at 0 and ends at the width, which is this value here. So we're going to define a for loop with the rows less than num rows, and we will push a new array on there. And then we'll go through each column and we'll take that array and we'll push an error character onto it. After all of these have executed, we've basically filled our grid with air characters. And so we want to now, lastly, make the start character this plus character just to mimic what's going on in the problem statement. And we'll return the board. Let's define a function called printBoard as well. That rather than print it as an array, which is going to have the brackets and all the commas and all that stuff, we just want to see everything looking nice and clean. So this takes in a board, which is a two-dimensional array of strings. And we're going to go through each row within the board. We'll create a variable called number_as_string or number_as_string, however you prefer to pronounce that. And we'll take index.toString of that. So for this for each function gives us the row and the index. And we're going to convert the index to string just because I want to see, basically like I have along the side here, I want to add the number of the row. Just if I'm debugging and logging, it'll help me with that. So while the length is less than 3, I add a space. This is just to make everything evenly spaced so that you're not seeing a shift on the board. I don't plan to go over 999, which is why I chose 3 here. And we can console.log that. So this will log the number as string, and then it's going to join the row. So this it'll join all the air characters after that. Now I'm going to define let board equal create empty board, which is our function up here. And now let's define a function called add rocks. This is probably the meat of what's going on here. I'm going to zoom in a little bit because we're getting serious now. But this is the meat of the logic that we're pulling from the input from. So we will loop through the first dimension, parsed input.length, and then the second dimension of that. And for that, we want to look at 2 adjacent coordinates. So we want to look at this coordinate and this coordinate. And basically we're seeing like, okay, if the x coordinate is the same, we know we're going to have a vertical line. So we need to draw the pound symbol from 122 to 118. X symbol is the same here again. Y symbol is different. Y symbol is the same, but X is different here. So we need to do the horizontal line in this case from 512 to 514 and so on like that. So that's what our logic here is going to do. So we'll get notice that J is equal to 1 here so that I can start from the first element and then we'll use -1 to get the element before it. And position 2. So we have I and J -1 and I and J. So if the x coordinate of pos 1 is equal to the x coordinate of pos 2, then we know we have a vertical line and we're going to let x equal pos1.x minus min x. We have to offset for our board. And we'll let start y equal the minimum of position 1.y and position 2.y, and end y equal the maximum of position 1.y and position 2.y, so that we have our good start and end points. Now all we have to do is loop through that and draw this thing. So for y is start y and less than end y, we will say board of y x equals to the pound sign. And now we have to do the same thing when we have a horizontal line. Very similar logic. So I'm not going to explain it, but if I see something, let's see. Yeah, again, we have to subtract min x here, which we didn't do up here because we're offsetting for how we built the board. Same thing with end x. Now we loop through and set the character how we need it to be. So we'll call add rocks on the board, which we already created up here with create empty board. And we pass parse input, and now we'll print board of board. And print board was this function that we went through before. So if I save, bring up the terminal, and run, now we can see we have this board. These are all of our rocks. So up here's the top, and the sand is going to start falling. Obviously, I don't have any sand yet, but we want to find how many units of sand have fallen when they come off the board here. So I'm assuming that they're all, all the rocks are probably going to get used in some respect, and then it'll fill this little container up, and then it'll spill off the side. All right. I'm not really assuming. I actually know that because I already went through this. Okay, so let's continue on. This is the next important piece of logic for simulating the sandfall. I'm going to switch to row column notation, vice x and y that I had up here. I always think this is kind of weird that we're calling y and then x. It just seems less logical to me, but you get used to it either way. But I'm going to do it this way. So let's define a function called getNextMove, and this takes in a position that's of type row column coordinate. And our next row is just going to be the row directly below. So we'll call pos.row plus 1. And if that is equal to board.length, then we know we've fallen off the board, right? So we will return null. Otherwise, if it's an error position, then we know that the piece of sand can drop. So error is below, next position is down. So we'll just return next row and the same column. We don't have to do anything else. Now we do have to do a little bit more processing when the thing below is a rock, or because then we have to simulate whether it falls left or right. So let's get into that. But first, I will actually define an out of bounds condition. Hopefully this doesn't happen, but I threw it into my code. So if it goes off the left side of the board or off the right side of the board, then we want to return null as well, because I would consider that a case where sand, there's never going to be a rock below it. So sand is falling off the board at that point. Okay, so now we're checking if the column to the left is sand. I think the problem statement says that first it's going to fall to the left. So we'll check this one first. Yep, we're going error to the diagonal left. So the next position is there. So we'll return this row column coordinate notation with row equal to next row and column equal to the column minus 1. Now we'll check the right side. It's going to fall diagonal to the right in this case. So we pass position.call plus 1. And lastly, the sand comes to rest. So it can't move left, it can't move right. It's going to just come to rest up there. So we'll update the board and reset the starting position. So the board at that position and that column, that position's row and column is equal to this character now. And we will return row 0 and column 500 minus min x. This is just our starting position right here. Yeah, I don't have anything above to show, but you'll see it in the next one. So let's define a function called part1 now, where we use this getNextMove to run our simulation. We'll define units of sand to be 0. We'll define an initial position of 0 and 500 minus min x. Again, same as what we had up here. And while true, we're going to getNextMove. So position equals getNextMove of position. So in theory, when we're just starting, position is the very top spot. We'll go into this function. We'll say next row is the row below it. And we know that the one below is a piece of air, so just we'll turn the next row, and it's going to keep iterating through that. If there's no position, so we get null, then we'll just return units of sand, because we know at that point that we've either hit this condition or this condition. So sand is no longer going to be on the board, and that's the answer we're looking for. And the other thing we want to do is we want to check if the sand has been reset. Then we need to increment units of sand, right? So we'll add a new unit of sand, and we'll go ahead and run our function here. So units part1 is equal to part1 of board. This is going to return that units of sand once the sand starts falling off the bottom. We'll print board to show you something fancy, and we will console log units part1 so that we can have our answer. So let me save, open up here, and run. And now you see this awesome visualization of our sand. So this is the empty board up here. You can see a new board starts here. Everything's falling. It fills up this thing, fills up this, comes down, fills up this, fills up this. I just thought this was really fun. And then it spills off the side here. The algorithm is a little bit funky. You would think sand would show up here. But if you look at the examples, this is the right case. And we get 610. So let's check that. 610 was the answer. Part 2, we're going to endlessly fill our box with sand until it hits the top. And so it wants to know how many units of sand come to rest again. The main thing we're going to have to do is we're going to have to expand the width of our board to account for all of this sand that's falling. And we're going to just modify some of our functions a little bit to get to that point. So I will clear, and let me close this. So we're going to need a wider board. Let's use the number of rows because that seems logical, kind of like building a square. So my thought process here is just give us enough room. We'll take the length of, I think we'll take the number of rows and we'll add that as air to either side of the board. So length to add is board.length. That's number of rows Modify board part 2. We also have to add a layer of air at the bottom and a ground. So you'll see how we do that here in a second. So for each row in board, we're going to define an array, empty array called air to add. We're going to go through by length to add and push the air symbol. And so row.splice, this is adding air to the left side, and row.push, this is adding air to the right side. Now we'll take the width of the board, which has changed now that we've added this air, and we'll define a new air row. So we're just making one empty row of air for the bottom, and we're going to push that to our board, and then we're also going to build a ground row, which is the number symbol, and push that as ground row. So we'll call modify board part 2 and print it. And let me bring this up here. We'll run. You can see it looks a bit funky here, but if I zoom out, start to make shape here. Yep, and so our board actually has sand in it from part 1. So just kind of ignore that right now. But you can see we've got a much wider board, and we've got our air row at the bottom and the ground row here. So let's cancel out of that and zoom back in. And we'll keep going. Get next move 2 is pretty much the same thing as get next move 1. The main difference here is when we update our offset now, rather than just minus min x, we also have to add that link to add because we changed the dimensions of our board. That's really all it is that's different about this. Everything else is the same. Probably should have reused the get next move from part 1 somehow for a dry code pattern, but we're just trying to get the answer here. So part 2 is going to be very similar to part 1 as well. We set our original position. We have a loop that just keeps going until we hit our breaking condition. We'll get next move 2 of the position. If we end up returning null, meaning sand is going off the board, actually, we return null. This is another change for get next move part 2. So I skipped over this. So it is a little bit more changed than part 1. The thing we're looking for here is this is the out of bounds condition, and this is if next row equals board.length. Never mind, I lied. It's still all the same. I'm the worst. I think it's going to be later here that we're going to check. Yep, so we know that we want to add a unit of sand if the position of sand is back at the top. And now what we're going to do is when the position of sand is back at the top, if we have already placed a unit of sand there, that's when we know our kill condition. So that's when we'll return units of sand. We don't expect sand to ever fall off the board, so this block of code will actually just never run. I just put it in there because I probably copy pasted it from part 1. Sorry about that. Okay, so now we're gonna run the code here to run everything. But first, since I have units of sand coming through from part 1, let's just comment this out. And I don't want to print the board at all for part 1 either. So, I do need to add rocks. So we'll leave that. And I thought I had printed the board one more time. Maybe not. Okay, let's save. Open up this, clear, and run. So we get 27,194. Let's zoom out so we can see how this thing looks. There it is. Amazing. Starting from up there and all the way down. You can see we used a little bit more than we need to, but hey, it doesn't hurt. Ran pretty fast, and yeah, we got everything we need. 27,194. Boom, the sand is falling. We are safe from the falling sand. Thank you so much for watching. If this video helps, your subscription really helps me, or like the video. There's a lot of people who watch these videos and don't subscribe, so don't let that be you. All right, I will see you for day 15. Talk to you later.
Yeah.